like to welcome you to another one of Sybil's Teacher Tip videos. Today we are going to focus on our hydrology student activity pack. Our first activity is called Properties of Water. For the first part, we need to get set up. For the setup, we need a cup of water that's filled about a quarter to a half of a whey, a cup of soapy water, and a cup of vegetable oil. They will also need a napkin for each of the liquids, a pipette, and a penny. Once this is set up, students are ready to go. Students should take the penny and place it on their napkin. They will then take their pipette and take some of the water and slowly and carefully begin dropping, one drop at a time, the water on the middle of the penny. They will count the number of drops they get until the water spills over the penny's edge. Once the water spills over the edge, that's too many drops, so they want to count up until it does that. Once it does that, they should record that number. They'll wipe off the penny and do this same process 2 more times for a total of 3 times. On the 3rd time, students should draw what the penny looks like from the side. They will then repeat that process with soapy water and vegetable oil. In part 2 of the activity, How Water Climbs, students will investigate how water climbs across a napkin. They will need to get 2 cups and a napkin to begin. Once they have their 2 cups, they will also need their purple flavor aid. Take a half a scoop of the purple flavor aid and put it in one of the cups. Fill that cup about a 1/3 of the way. They can stir it around if they like. Okay. Open up the napkin and then tear, or if they have scissors, they can cut it into the 4 equal pieces of the napkin. We're going to use the other pieces in the other parts of part 2. So they just need 1 of the 4 squares. They're going to fold it lengthwise once and then again. Once they have it folded, take the piece of paper, stick one end in the purple side and one in the empty side. Have students draw this setup. After 24 hours, they'll look at their setup again and draw it. The next part is going to involve 3 cups. They should take their 3 cups and line them up next to each other. On one of the cups, they should place a half a spoonful of purple flavor aid. Fill that about a 1/3 of the way, just like they did before. If they go a little bit more, that's okay. Then they're going to take their red flavor aid and put it in the furthest cup away from the purple. You're gonna fill that, the 1/3. Stir it around. Next, grab 2 of your pieces of napkin that you have already ripped and create your napkin bridges. So there's 1 and there's 2. Okay. Have students predict what they think will happen to the water once you place the napkins into the cup. Once they have their prediction, have them place the napkins into the cup. One end in the liquid, the other end in the empty cup in the middle. Have them draw their setup. Set it to the side. Once they come back to class after 24 hours, have them look and draw their cups again and compare their results to their prediction. The final part of the climbing water activity is exploring how temperature affects capillary action, or the movement of water. Students should prepare 2 cups with purple, just as they did before, and set them next to 2 empty cups. The biggest difference is that the 1 cup is going to have ice and the other cup is going to be warm water from the tap. We'll start with the cup with the ice. They should make a prediction as to how they think temperature will affect the rate in which capillary action occurs before getting their napkins and folding them. Once they have their prediction set, they should grab 2 pieces of napkin and fold, just like they did before. As soon as they place the one end in the cold water, they should hit start. They'll watch it climb over the napkin, and as soon as the water droplet hits the bottom of the empty cup, they should press stop. That will be their time it took for the cold water to cross over the napkin into the empty cup. They will repeat that same process with hot water. They should record that time as well. At the end, they should be able to compare the results to their initial prediction of how temperature affects capillary action. Activity 2 is called flinkers. In part 1, students are going to create a flinker. A flinker is an object that neither sinks nor floats. For this activity, they'll take a tall cup of water, 2/3 to 3/4 of the way full, use their bag of sand, and their vial. This is a waterproof cap, so it can be a little tricky to get on and off because it has a tighter seal. How students want to do this is they should take their sand and a little spoon and fill the vial up to where they think the sand should be to cause this vial to flink. What's fun about this is that students will fill it too much, too little, and that's okay, right? So they fill it up and they realize that, well, that amount floats, it's not flinking, so how do I change that? Once they get the object to flink, they want to take a look at and see what was difficult about the challenge and then what adjustments did they make. At the bottom, there's a small writing about density. And after they read that, using the information from this paragraph as well as what they just experienced, we want them to compare the density of their flinker to the density of the water. For part 2 of the activity, which is located on the back, we're going to explore salt water and the flinker. So have the students remove the flinker from the fresh water once they have shown you that it is in fact flinking. Okay, so they're going to remove it. They will need some salt from their house, so just they could grab a salt shaker or the little thing of salt, grab a spoonful, place it in their water, stir it around so it dissolves, and then place the flinker back into the salt water. What do they notice now about their flinker? What adjustments are they going to have to make? So they take the flinker out, they make their adjustments and get it to flink in the salt water. Then, based on that information, compare the density of the flinker to the salt water. In part 3 of the activity, we are going to compare salt water and fresh water. And to do that, we're going to need 2 cups, about 2/3 of the way full. To make sure that we can see the difference between the salt water and the fresh water, first thing we're going to do is we're going to add a little spoonful of purple flavor aid. We then are going to add a couple spoonfuls of salt to make it salty water. Mix it around. Before the students pour the cups, have them make a prediction as to what they think will happen when you take the purple salty water and pour it slightly down the edge of the cup. Once they've made their predictions, have them take their cup and slowly on the edge begin to pour their purple water. and watch what happens. What's nice is that once it starts to level out a little bit, students will start to see that the cup has formed a layer. At the bottom, you see that nice dark purple layer, and at the top is where that fresh water is. Based on that information, the students then compare the density of salt water to fresh water. The final part of this activity is looking at different temperatures and how temperature affects density. So in this case, we're going to use salt water. We just did a comparison of salt versus fresh. So now we're going to look at the different temperatures of salt water. So we are going to create 2 different cups of salt water. One of them will be warm. The other one, once again, so we can see the difference, we're going to add a scoop of the purple flavoring. We're going to stir it around, and then we're going to add some ice cubes. I already threw some ice cubes in there. Have students make a prediction as to what they think will happen when you pour the cold salty water into the hot salty water. Once they have their prediction, go ahead and have them slightly pour the water and take a look at what happens. What's fun is if they hold it up to the light, they get to see a really nice purple layer to show them that the cold salty water sinks to the bottom of the warm salty water. Based on that information, they'll be able to compare the density of colder water to warm water. The third activity is called water filtration. To do this activity, students will need both types of coffee filters, their napkin, small cup, sand, their red Kool-Aid, and their tall cups. To begin, students will take a scoop of sand and place it into their small cup. They should add about 2/3 water, stir it around, and write what they notice. They then should take 1 cone filter and hold it up to the light and document any of their observations. What do they see? They're going to do the same thing for the basket filter and the napkin. With the napkin, they're not going to unfold it. So they're going to keep it and look at the light. Based on that information, they should make a prediction as to which filter they believe will remove the most amount of sand. Once they have their prediction written, they should start with the cone filter. Take one of the tall plastic cups and place the cone filter into the cup. Before they pour their water, they should stir it up again. Hold the filter and then pour. They're going to hold on to the filter and watch it drain out the water until it is completely drained. After a little bit, they should be able to let go and the filter should stay. Students should label the cup to say that this is the cone filter. They're going to repeat that process of adding sand and water and then using 2 more cups with the 2 other filters to complete. Once they have all 3 of the filters completed, they should compare the water and use their results to then go back and look at their prediction. Part 2 of the activity is called turbidity. Students will get a chance to determine the turbidity amount of the water that they just filtered out. To do this, we're going to use the turbidity chart on the back of the student activity guide. Simply place it down on someplace flat, take one of the water samples that they just filtered, and place it over the middle circle that's located in the rectangle. Students will look directly over the cup and compare that center circle to the outside 6 circles. Based on that information, they'll be able to write down in the amounts of JTU what the turbidity of the water is. They should do that with all 3 samples. Once they get their 3 numbers, they'll be able to determine which water has the highest turbidity and which has the least. Part 3 of the activity is looking at the layers of filtration. Students need to take 2 napkins. They're going to take the first napkin and hold it up to the light. They're going to take a second napkin, unfold it, and hold it up to the light. What do they notice about the difference in the napkins? The next step, students will create their dirty water with sand, just like they have before. In the first one, they will use the unfolded napkin, just like they did previously, and pour the water in. It's really important with the napkin that they hold on to it until it gets going. So we'll let that one filter as we prep the second cup. Now we're going to use the unfolded napkin. So we can place it over. It helps sometimes to create just a little bit of a dip in there for the students. And once again, hold the napkin and slowly pour. When this is done filtering, students will then compare the 2 together. They should then take the 2 different cups and one at a time place them on the turbidity sheet. How did the turbidity change between the different layers of filtration? Part 4 of the activity, we are going to look at, is the water safe to drink after just doing simple filtrations? So we need to create our dirty water. So we're going to grab our sand, put a scoop in. Then we're going to take our red Flavorade. This represents any organisms or microplastics that we might not be able to see with the naked eye. We're then going to put in our water. Okay. Before we filter, students will make a prediction to if they think the cone filter, which in part 1 did a good job of filtering out the sand, will be able to filter out the powdery drink mix as well. Once they make their prediction, they're going to place their cone filter into the cup. All right. We're going to take their mixture and carefully pour. They'll allow the water to filter through, and they'll be able to make observations on the water, but also inside the filter as well. Using their evidence from both the filtered water and inside of the cone, students can then explain if filtration is enough for water to be safe to drink. They can then research and explain other ways that we make water safe and potable. And that is our hydrology student activity pack.